this is going to be based on the quotient rule, and we're taking derivatives. And I want to remark that the derivative of a quotient simply is not, and I'll say is not, quotient of derivatives, meaning you don't say that this is actually equal to f prime x over g prime x. That's probably the biggest mistake that people make. The quotient rule, as we proved in class, is given by this formula. And let's note that this is a quotient. You got f over g here. And our formula is going to be essentially, if you really look at this, we're going to square the denominator function. That's g squared. And then bring g up here. Don't forget to multiply by the derivative of f, the numerator function. And now you're going to subtract f and multiply by the derivative of g, the denominator function. So keep in mind, you have a couple of things happening here. F is the numerator function. G is the denominator function. You're going to have to keep track of the numerator and the denominator when you use quotient rule. And it starts by taking the denominator squared times that denominator multiplied by the derivative of the numerator. And don't forget, it is always subtraction here. Subtraction. Now you multiply by the numerator function times the derivative of the denominator function here. So this is what you're looking at. This is going to be our quotient rule. Okay? So let's look at this quotient rule in action. Let's look at the first example. They give us a function f, which is x over x plus 5. Now, this is a different f again. Okay? This is the f in our quotient rule. This is the g in our quotient rule. So call that h if you like. And again, we can write this all in operator notation, meaning we can say the derivative of x over x plus 5. Okay? And again, f, g, that will be, let's write it out this way, square the denominator function. Okay, square that function. So squaring g means taking your x plus 5 and raising that to the second power, because that's the denominator function. That's your g. Now, bring that same function up here, meaning you have x plus 5 here, and we put that in parentheses. So you start with g now, and now you multiply by the derivative of f. Derivative of f, we'll write in operator notation. You subtract. So this will be minus f now times g prime. So you can write it as f times g prime like we did up here, or g prime times f. We're using this quotient rule. So f is our numerator function. So we're going to say this is times x now times the derivative of the denominator function g, x plus 5. So that's how we start this process. And we now have to take our derivatives. So if we differentiate x, that'll be 1. Differentiate x plus 5, that's also 1. We end up with the following. X plus 5 squared, this would be x plus 5 times 1 minus x times 1. And as we multiply, you get x plus 5 minus x, everything over x plus 5 squared. So when I combine my terms here with the x and the minus x going away, this function will become 5 over x plus 5 squared. And you're done. This is how we use our quotient rule. Okay? Number 3. 2x over x minus 8. So as we put this in operator notation, 2x over x minus 8, here's what you end up with. Here's your f, here's your g. Remember, square g, take g, multiply it times the derivative of f, the numerator function, subtract now the function f times the derivative of the denominator function g. What that looks like in operator notation is simply going to be the following. Take the denominator g and square it. Take g, multiply by the derivative of f, subtract f times the derivative of g. Two. 1. These are my derivatives. Now we're going to have to do some algebra here. We get x minus 8 times 2 minus 2x times 1, everything over x minus 8 squared. So as I do my distributive property and I multiply here, we get 2x minus 16 minus 2x, everything over x minus 8 squared. 2x minus 2x, this gives me negative 16 over x minus 8 squared. So this will be my final answer. And this is number 3. This is our quotient rule. Number 5. F of x will be x minus 4 over x plus 3. Now, in terms of operator notation, dx, x minus 4 over x plus 3. We're going to remember here that this is my f, this is my g, this is a different f. Call it h. So, we're going to square g. We're going to take g, multiply it by the derivative of f, minus f times the derivative of g. So now you take x plus 3 squared times that x plus 3 times the derivative of x minus 4. Now you subtract x minus 4 times the derivative of x plus 3. One. Take those derivatives. So you end up with x minus 3 times 1 minus x minus 4 times 1. Everything over x plus 3 squared. So as I distribute now, here's what we end up with. X minus 3 minus x plus 4. Everything over x plus 3 squared. So as I combine my terms, x and minus x goes away. And don't forget here, negative 3 plus 4 gives us really positive 1. So this derivative will be 1 over x plus 3 squared. And you're done. So this question is number 5. Number 7. Here's our function. Two x minus 9, x squared minus 1. In operator notation, 2x minus 9 over x squared minus 1. Here we have f, we have g. Erase this. You have what? H, because this is a different f function. As we've seen in class and as we've seen in the other videos and worksheets. So let's remember our quotient rule here. You're going to square g, the denominator function. G times f prime minus f times g prime. So we're going to follow this format. So back to our operator notation, and we get x squared minus 1 squared times x squared minus 1 times the derivative of 2x minus 9 minus 2x minus 9 times the derivative of x squared minus 1. And so you also have g f prime f g prime. So this derivative here now is 2, and this will be 2x. X squared minus 1 times 2 minus 2x minus 9 times simply 2x. Everything over x squared minus 1 squared. So let's double check. So we'll end up with 2x squared minus 2 minus 4x squared plus 18x. So let's be careful here. Don't forget, you're going to take 2x times 2x, it gives you 4x squared. But there's a minus sign out here. This is why it's minus 4x squared. And then, if I do this, let's erase this here. We're going to take the 2x times negative 9, which gives us negative 18x. But again, don't forget there's a what? Minus sign. This is opposite. So this is why we end up with what we have. Over x squared minus 1 squared. Now when we combine our like terms here, 2x squared minus 4x squared, here's what we end up with. Negative 2x squared plus 18x minus 2, everything over x squared minus 1 squared. Here is our h prime x. And there you go. I could remark about something here, so let's note. For this function, if you look in back of the book, you're going to see a minus sign here at the same level with x squared minus 1 squared. Now, what they did here was factor out a negative 1 from each term, and they're going to put it in the numerator. So if you look in back of the book and you see this alternate version, it's because they factor out that negative 1. And all they did was put the negative 1 at the same level as their division sign. So either way for now is fine. And here you go. This is your derivative of 7. Number 9. F of x. 5x over x squared plus 7. Operator notation, d dx, 5x, x squared plus 7. Here's my f, here's my g. By quotient rule, g squared, g times f prime minus f times g prime. And again, you may say, is this the same f? No, it's not. So if you like, call that h. So let's go through the details now. Take g, x squared plus 7, and square it. You're left with x squared plus 7 times the derivative of 5x minus 5x times the derivative of x squared plus 7. This derivative is 5, and this is 2x. X squared plus 7 times 5 minus 5x times 2x, everything over x squared plus 7 squared. Distribute and multiply. We get 5x squared plus 35 minus 10x squared. Everything over x squared plus 7 squared. So when you combine your like terms now, for this derivative, we'll have negative 5x squared plus 35. Everything over x squared plus 7 squared. And you're done. This is question number 9. Question 11. For x plus 3, 5x minus 7. Operator notation, d dx. 4x plus 3 over 5x minus 7. So here you're going to have your f and your g. G squared, g times f prime minus f times g prime. Five x minus 7 squared, you get 5x minus 7 times the derivative of 4x plus 3 minus 4x plus 3 times the derivative of 5x minus 7. So if I take the derivative here, we get 4. This derivative is 5. We end up with the following. 5x minus 7 times 4 minus 4x plus 3 times 5 over 5x minus 7 squared. And we get to distribute. Here we go. 20x minus 28 minus 20x minus 15. Everything over 5x minus 7 squared. So we're going to combine our like terms here. 20x and minus 20x cancel. And don't forget here, negative 28 minus 15, we're going to add those. So we're going to end up here with the final answer going to be 5x minus 7 squared. Looks like it's going to be minus 43. Here you go. And that's a 5. Number 13. Our function here is the square root of x over x plus 5. So I'm going to differentiate the square root of x over x plus 5, a quotient. Using operator notation, I have f, I have g. You might say, is this the same f? No, so call it h. G squared, g times f prime minus f times g prime. Take g, x plus 5 squared. Here's my g. We're going to differentiate x to the 1/2 minus x to the 1/2 times the derivative of x plus 5. So let's take a closer look here, because you may notice the square root of x is x to the 1/2. So here's going to be my f function. Okay, remember, this here is g squared. This is g, f prime minus f g prime. Okay, let's get rid of some of this here so we can do some work and take a look at some detail. This derivative, 1 over 2 square root of x. Like I said, it's always good to have that memorized. I mean, even though you worked on it by definition, finding that derivative, even though we worked on that by using the power rule, we've seen this over and over again. We don't have to go through those details if we know it. So I have it memorized, and every time I have to take the derivative of the square root of x, it's 1 over 2 square root of x. Now, derivative of x plus 5, just like you know the derivative of x is 1 and the derivative of constant is 0, and the derivative of sum is sum of derivatives, we know that one too. So the work really comes down to some algebra here, meaning we have x plus 5 here times 1 over 2 square root of x minus square root of x times 1, everything over x plus 5 squared. So let's do a little bit of arithmetic here. Let's do a little bit of simplifying. We're going to distribute first of all here. So let's do that. We get x plus 5 over 2 square root of x minus square root of x over x plus 5 squared. So we're going to start to do some simplification, and here's what I mean by that. We're going to take, let's just start first of all remembering that we are going to subtract two rationals. So we're going to put that over 1, and we're going to subtract two rationals. Now, what that does mean, if we're going to subtract rationals, we have to have the same denominator for those two rationals, and right now they're not the same. So we're going to have to multiply the bottom by the square root of x and the top by the square root of x. Remember, we multiply fractions straight across here. So here's what we're going to end up with, so you know. The denominator here is still x plus 5 squared. But all our work that we're going to do here now is right here. We're going to work with that numerator. Now, let's take a look. We end up with x plus 5 over 2 square root of x minus, this will be here, square root of x times square root of x. That'll give you just an x. And then down here, we have 1 times square root of x, which will simply give us the square root of x. Now remember, there's also a 2 here. So we need to multiply as well by 2. And that gives us 2 and 2. So we could have started by saying we're going to multiply by 2 square root of x. That would have been fine. But as you guys can see now, we're now able to subtract our rationals. So if you like, go back and you can erase all this stuff. And you can say, could I have simply done this, multiplied by 2 square root of x, 2 square root of x? The answer is yes. Here's what we have. The numerator, and there is a numerator, there's this whole expression. We're going to write this as x plus 5 minus 2x over 2 square root of x, because we could now subtract our rationals, okay, so they have the same denominator. Now it's important for you, and I'll put this in red, to notice we're going to divide by here x plus 5 squared, because we're really dividing, here's the division, by, you can think of as a whole number, x plus 5 squared. So we wrote this vertical definition of division horizontally, and you're going to see how that's beneficial for us. So now, when we combine our terms here, we have 5 minus x on top over 2 times the square root of x. Let's focus on this division of a whole number, which really means 2 multiplied by the reciprocal of that whole number, x plus 5 squared. Now it's not a number, but it's a term, and it works the same way. So remember, how do we multiply now? Straight across, and I mean horizontally across. So 5 minus x, if you look at this, times 1 will give you simply 5 minus x, and then 2 times the square root of x times x plus 5 squared. So we get 2 times the square root of x times x plus 5 squared. This here is the derivative of our function here. And you're done. Here's 13. We now have to go to 15. F of x becomes the square root of x plus 5 over the square root of x minus 2. So by operator notation, d dx, the square root of x plus 5 over square root of x minus 2. Here's f, here's g. Is that the same f? The answer is no. There's an h. Now remember, you get g squared, g times f prime minus f times g prime. So the square root of x minus 2 squared here, square root of x minus 2. This is where we start with our g. Differentiate the square root of x plus 5 minus the square root of x plus 5 times the derivative of the square root of x minus 2. So we're now ready to differentiate here. 1 over 2 times the square root of x. 1 over 2 times the square root of x. So as you guys can see, it is very beneficial to have that derivative memorized as well. So let's put all this together, because now the work's going to be simply some algebra. But you see, the prior problem will help you do this problem, meaning we have the square root of x minus 2 times 1 over 2 times the square root of x minus the square root of x plus 5 times 1 over 2 times the square root of x. Everything over the square root of x minus 2 to the second power. So now you're going to distribute. The square root of x minus 2 over 2 square root of x minus the square root of x plus 5 over 2 times the square root of x. Because remember, when you multiply here, let's put this in red. You multiply straight across. And then don't forget, you're going to divide by square root of x minus 2 squared. We're going to divide by this. Now, let's look at some details here. We're going to subtract two rationals, and the good news is they have the same denominators. So what that means for you here will be the square root of x minus 2 minus the square root of x minus 5. Everything over 2 times the square root of x divided by the square root of x minus 2 squared. Don't forget, we're doing what we did before. We're dividing here by a whole number, which is what you see here, dividing by that whole number. Now, I'm going to get rid of some of this stuff, or maybe I'll just leave it here for now. Let's see what this gives us. When we simplify, these terms will cancel. I'm left with a negative 2 minus 5. So we end up with a negative 10 over 2 square root of x times now, and I'll change that color, times 1 over the square root of x minus 2 squared. Because we're working here with how to divide a whole number, you multiply by the reciprocal. Okay, let's get rid of some of these things here. Okay. Now, when we multiply again horizontally across. So you end up here with negative 10 over 2 square root of x times the square root of x minus 2 to the second power. Now notice you can simplify here. 5 and 1. Excuse me. So your derivative will be negative 5 over the square root of x, the square root of x minus 2 squared. And you're done. So this here is using the quotient rule for number 15. And you have to go through all this algebra here. Number 17. F of x is 6x squared over x squared minus 5x plus 3. So, using operator notation, d dx of 6x squared over x squared minus 5x plus 3 here's your f, here's your g. Now remember, here's what we're going to do. By now we should know this formula. We're going to have to square our g. X squared minus 5x plus 3 becomes squared. X squared minus 5x plus 3 is squared, times the derivative of 6x squared minus 6x squared times the derivative of x squared minus 5x plus 3. So you really have here g squared, g f prime minus f g prime. Now we take our derivatives. 12x, 2x minus 5. So here's what happens now. Now let's go back. I see a typo here. This is not squared because remember, this will be r. This is g squared, and this is g. So let's be careful there. So that's not squared. I'm glad I found that. Anyway, let's see what kind of algebra we're going to have to do. X squared minus 5x plus 3 times 12x minus 6x squared times 2x minus 5. Everything over x squared minus 5x plus 3 to the second power. So we're going to now have to do, we're going to multiply here. Distribute. 12x cubed minus 60x squared plus 36x minus 12x cubed plus 30x squared. Everything over x squared minus 5x plus 3 squared. So now we're going to look at combining our like terms. 12x cubed minus 12x cubed. My 12x cubes are gone. We're going to have a negative 60x squared plus 30x squared. That's going to give me a negative 30x squared. We're going to have plus 36x. So this will be plus a what? 36x. Everything over x squared minus 5x plus that 3. And don't forget that that is actually squared here. So we don't have to actually square this. Let's rewrite this here. We don't have to square our answer. So h prime x will be minus 30x squared plus 36x, everything over x squared minus 5x plus 3 squared. You are done. Here's our derivative. And it looks like that was question number 17. Yes. And we now go to 19. F of x for number 19 will be x to the fourth over 1 plus the square root of x. So that this derivative function, the derivative of a quotient, x to the fourth, 1 plus the square root of x, here's my f, here's my g, g squared, g, f prime minus f, g prime. One plus the square root of x squared. There's my g squared. 1 plus the square root of x times the derivative of x to the fourth minus x to the fourth times the derivative of 1 plus the square root of x. So here's what you get. 4x cubed 1 over 2 times the square root of x. So 1 plus the square root of x times 4x cubed minus x to the fourth times 1 over 2 square root of x. Now notice what this really gives us. We can actually directly write this way. We could just simply put this over 2 times the square root of x. Don't forget, 1 plus the square root of x squared. So we're going to have to do some algebra here. So let's take a look at what we'll need to do. Distribute. And over here, we can use properties of exponents here. This is what we mean. X to the 4th over x to the 1/2 becomes x to the 4 minus 1/2. X to the 8/2 minus 1/2 is x to the 7/2. This is what you have here. So I get 1 plus the square root of x times 4x cubed minus 1/2 x to the 7/2. Everything over 1 plus the square root of x squared. So now when I distribute here, 4x cubed plus 4x cubed times the square root of x minus 1/2 x to the 7/2 power. And here's what we're going to do. We're going to put this in a parentheses here. Oh, we're okay. We're fine. This is over 1 plus the square root of x squared. Now, the only thing that's left to do here is really simplify this radical, because what you have by definition of x to the 7/2, this portion here is really the square root of x to the 7th. Now that could be simplified. Write this as x to the 6 times x, the product rule, and this is x cubed square root of x. So we're going to replace this x to the 7/2 up here with what you guys see in terms of written as a radical x cubed times square root of x. So here's our final answer. H prime x will become 4x cubed plus 4x cubed square root of x minus 1/2 x cubed square root of x, everything over 1 plus the square root of x to the 2nd power. And you're done. This is number 19. Number 21. F of x is 2x squared plus 1 over x to the 4th minus 12. So when we use the quotient rule, d dx, 2x squared plus 1 over x to the 4th, let's be careful, operator notation, 2x squared plus 1 over x to the 4th minus 12. F, G, this is G squared, G times F prime minus F times G prime. Here's what you end up getting. X to the 4th minus 12 squared, x to the 4th minus 12 times the derivative of 2x squared plus 1 minus 2x squared plus 1 times that derivative of x to the 4th minus 12. 4x cubed. So x to the fourth minus 12 times 4x minus 2x squared plus 1 times 4x cubed, everything over x to the fourth minus 12 squared. So you're now going to take, or you're going to distribute here. See some algebra. 4x to the fifth minus 48x minus 8x to the fifth minus 4x cubed. And this is all over x to the fourth minus 12 squared. So you're going to distribute here. Now be careful, because this is here a subtraction sign. So when you distribute, in this portion, all the signs will be opposite. And so the only terms that are left to combine here will be these two. So our final answer here will be h prime x to the fourth minus 12 squared, and that's minus 4x to the fifth minus 4x cubed minus 48x, because we combined these two terms. And we wrote this answer in what's called descending powers, descending order. You can look in back of the book, let me know. And you can see an answer where they factored out the negative 4 from a numerator. You say, why did they do that? Well, because they can. And you factored this out. And you can see a couple of things. You can see negative 4 now times x to the fifth plus x cubed plus 12x, everything over x to the fourth minus 12 squared. You can see your answer this way. Or you can see the answer where they put the negative sign at the same level as your division sign. And now they have a 4 here times x to the fifth plus x cubed plus 12x. Now you might say, couldn't we factor out? Because if you take a closer look, can't we just factor out the greatest common factor? Can't we factor out even an x term? And you're right. So you can have minus a couple of things. 4x, x to the fourth, plus x squared, plus 12 over x to the fourth minus 12 squared. So you can see this as an answer as well. So these are all similar, where they went back and they said, we see a multiple of 4, we can factor that out. We see a multiple of x, they're going to factor out the x. And what you see here as the final answer is right here. They just did some factorization. And furthermore, if you want, put this minus sign at the same level. And these are the answers that you can see. So this was number 21. And it looks like that concludes our exercise here.